everyone. Good day to all of you and welcome back to the channel. Today we are going to talk about something really important, especially if you are working in industries like oil and gas, chemical and food processing or pharmaceutical industries. We are going to understand a tax zone classification and how it helps us prevent fire and explosion accidents in workplaces. Now, you might be wondering what exactly is ATEX? Well, ATEX stands for Atmospheres Explosibles. It's a French phrase that simply says explosive atmospheres. In simple terms, ATEX is a safe guideline that helps industries identify areas where flammable gases, vapors, or dust might be present and where there is a risk of explosion. Once we know which areas are hazardous and we can take the right safety principles like using a special equipment like flame-proof equipment and flame-proof fittings and controlling ignition sources and training people to avoid accidents. So, in today's video, we will break down how these zones are classified and what kind of materials can create explosive atmospheres and how this knowledge help us stay safe at work. Let's get started. The objective of attack zone classification first to identify how often an explosive atmosphere can occur and how long it can present in that area. And second, to assess the chances of ignition sources being present and strong enough to trigger an explosion, meaning that how the source of release and how much time it will be released and how long it will be persist in that area. And third, to evaluate whether the installed electrical instrumentation equipment in that area could become an ignition source. So this helps industries plan safer equipment installation and improve overall plant safety. When can a substance form an explosive atmosphere? Before we classify zones, we need to understand when a liquid or gas can actually form an explosive atmosphere. And there are two main conditions to check for the liquid to form the explosive atmosphere. And first one, if it is flash point is below 60 degrees Celsius, it can easily form flammable vapor. So example, petrol as a flash point around minus 43 degrees Celsius. So it's highly flammable. The second category, even if the flash point is above 60 degrees Celsius, if the process temperature is at or above the flash point, it can still release flammable vapors. In example, we can say lubricating oil with a flash point of 150 degrees Celsius used in a heater and process a temperature at 140 degrees Celsius. So this can also form an atmospheric explosion, means an explosive atmosphere. And this helps us judge whether the substance can ignite easily in that zone. Let's see about gas and liquid forming a zone classification. And gas and flammable vapor zones are classified zone 0, 1 and 2. Let's now look at how areas are classified based on the presence of flammable gas or flammable vapor. First we look zone 0. Zone 0, a high risk area. This is where an explosive atmosphere is present continuously or for a long period during normal operation. Say example, inside a fuel storage tank, flammable vapors are always present. So this area can classified as a zone 0 since it's having always a flammable atmosphere. And zone 1 is a medium risk area. Here an explosive atmosphere is likely to occur occasionally during normal operations like around the manhole of underground diesel tank or near a vent pipe of the reactor. So this area can be classified as zone 1. In zone 2, it's classified as a low risk area. An explosive atmosphere is not expected during normal operations, but it might occur if something goes wrong, like a leak or near a pump seal like that could leak or around the dike wall of a chemical tank. For the dust, the zones are classified as zone 20, 21, and 22. Like zone 20 is a high risk, and zone 21 is a medium risk, and zone 22 classified as a low risk area. The main criteria for to form an explosive atmosphere for the dust, there are two things. One is the particle size, and second is how much concentration in that area. The particle size should be less than 500 micron, and the suspended in the air in the right concentration of the dust is the second criteria. If these two criteria, if it is meets, then there is a lot of more chances to form an explosive atmosphere for the dust handling areas. Attack zoning help us first understand which areas are hazardous, and second know how often explosive atmosphere can occur in the industry or in any place, and third choose the right equipment and to take the safety measures. Next video we will explore how to select equipment based on attack zones, so make sure to subscribe and stay tuned. If you found this helpful, give it a thumb up and drop your questions and thoughts in the comments. Stay safe, keep learning, and see you in the next video. Bye bye.